So hello everyone, my name is Avinash Vadhude, and today I am giving a presentation on my recent project, which is SpaceX Falcon 9 first stage landing prediction. So first I give the overview of my presentation. First I give the introduction about the SpaceX and then Falcon 9 project, and second we talk about the problem statement, and then next we go through the data collection and data wrangling and processing techniques and what kind of process I use during that. And the next we analyze the data with the help of exploratory data analysis. Then we apply all that learning into the machine learning models, and then after we fine tune the model and evaluating the model by applying that data, the key result and insight which I get during the process, and what kind of challenges I face, and what kind of limitation the project is carry out. And at the end we go through the conclusion of my project and what kind of future works we are working on that. And at last I give the shout out to the my resources and my mentors. So this is overall walkthrough. So let's get started. So in the introduction, I give the overview of SpaceX. The SpaceX is a space exploration and technology corporation, which is founded by Elon Musk in 2002. The headquarters is located in the California, USA, and the vision of the company is to reduce the space transportation cost. This is the main purpose of founding the company, and it is enable a mass uh, colonization. And what kind of milestone they achieved till now is it is the first private company to launch orbits and return a spacecraft, and it is the first private entity to send astronaut to the ISS International Space Station. And if we talk about the Falcon 9 project, so it is designed particularly as a reusable rocket, which is medium lift launch vehicle. It consists of two stages, and one payload. And in first stage, they have a 9 Miracle engine. Second stage, they have one Miracle engine, and payload carry the satellites, drones, spacecraft, etc. And it is first launched at in June 4, 2010, and the milestone is achieved the first commercial rocket to launch human into the orbiter in 2020. So there is a large gap between them, 10-year gap to successfully achieve the milestone. So it is a very big gap. So if if I talk about my problem statement, uh, how can we predict the success of Falcon 9 landing? So and what factors influence landing success? What kind of factors their effect for the landing of first stage, and how can machine learning enhance their prediction accuracy? So it is our main purpose. And why it's matter, because reusability reduce launches cost. As we know, the NASA, if I want to launch rocket, so NASA took around $165 million cost to launch one rocket, and with the help of SpaceX reusable technology, they launched their rocket uh, with the cost of only $62 million. So it is very big gap between the cost, and it help uh, better financial planning for the other competitor, I can say, at the time of bidding. So in data collection, I collect I collect the data which I needed for the project from SpaceX API and other launching details from that, and external data set I use like a weather data, location data, and what kind of launching site data, etc. data. I use various types of resources from the internet for collection of data. And you if we see that which data I collected, it is like in that format. It is a unstructured data. So my first task is to clean that data and convert that unstructured data into structured data. So so how the data wrangling and pre-processing is started by following the steps like keep cleaning the missing value which is present in the dataset, like a duplicate or value also, and renaming the proper feature by using a feature engineering process like a payload weight, weather condition, launch site, and encoding categorical data also, and scaled a numerical feature. So I use this step-by-step process at the time of data wrangling and pre-processing. And if you see that chart like a data wrangling, I there is a missing values are there. In the payload mass they have 5 missing values, and in the landing pad there are 26 missing values. So I have to done some work on that. And we have the 4 launching site there, like CLC 14, LC 39A, and CLC 4E. There are 3 launching sites. So after applying that data processing techniques, I come up with that structured data. Structured data it looks like they have consist of various types of feature like flight number, date of the launch, rocket, and the booster version, what kind of version they have, Falcon and Falcon 1, and the payload, how much load the rocket is carrying out in the unit is Newton, and what the rocket is launched in which orbit, like a LEO orbit or ISS orbit. LEO means very low Earth orbit, and ISS means International Space Station. It's like that. And they have the launching site also. There are 3 types of launching site. What kind of outcome, flight, red frame, reuse legs, and landing pad, block, reuse count, series, uh, longitude and latitude. They have the various it is the various type of feature the data carry out, and we are focusing on that reuse feature, because if the false is written in the dataset, it means they failed to land successfully. If the return true, then it is successfully landing. The first stage is successfully landing on the site. Then after the clean data, we start our exploratory data analysis by using various types of chart, by understanding the data and correlation with the feature. I analyze the data and I come up with the insight. So I explain one by one with the help of chart. So as we see the first scatter plot, I took uh, payload mass in x-axis and orbit in y-axis. As we see that there is a GTO, some correlation, there is a ISS, some correlation. So we observe that the heavy payload have a negative influence on GTO orbit and positive on polar LEO and ISS orbit. And in second scatter plot, we see that there is a very rich correlation between a uh, last last site launch site. Most of the launching were carried out by SLC 14, followed by next is LC 39A, and at last SLC 4E. In the next scatter plot, we see that in x-axis I took flight number, and in y-axis I took a launching site. So there is a the success of landing increase as flight number increase. We we see the observation like that. When the flight number is increased, then automatically the success rate of landing is also increased. In the line chart, we see the relationship between success rate and year. So as we see that we can observe that success rate since 2013 keep increasing till 2020. After 2030, the success rate is increased because the SpaceX increased the uh, number of flights also. That's why. And in the last bar chart, we see that the relationship between success rate and orbit. So as we see, they have four orbit have the 100% success rate. First, first orbit is ESL1, GEO, HEO, and SSO have the highest success rate of 100%. And I also use the map to visualize the various types of launching site. We have the various types of location, so I used a map to show that data with the help of map. And I also calculate the distance between the two launching site also. So after that I applied that data on machine learning model, like various types of machine learning model. I applied that data like support vector, machine classifier, decision tree, KNN, and logistic regression. Also, I use six machine learning model to uh, find out which algorithm is fit for the which machine learning model is fit for my data. I follow that step. First step is I standardize data. Already I do that. After that, I split the data into two types: training data and test data. And after that, I find the hyperparameters for applying the dataset and find the method perform best using the test data among all classification model. So there is a screenshot of my notebook, Jupyter notebook, how I apply the data into the model. There is the first I split data in this process and apply the logistic regression problem, and here is the accuracy of 0.82 means 82%, and there is a confusion matrix also. So after applying all machine learning models to the data set, with the conclusion is that for training data, the best algorithm is random forest with the accuracy of 100%. And for the test data, the best model is extreme gradient boosting classifier with the accuracy of around I think 88%. Hmm. So after that, I see that as you see the model training and evaluation hyperparameter which is I use is grade search and randomized search. I use this hyperparameter and the best performance model for training data is random forest classification with the accuracy of 100%, and test data like the best fit model is extreme gradient boosting classification with the accuracy of 88%. And here is a key result and insight I get after performing the previous activity. The model achieve high accuracy in predicting landing outcome. and payload launch site and whether significantly impact the result of landing, and reusability improve with the precision landing on ground pads. These are the key insight I find. And what kind of challenges I face? Not much challenge, but that they have the limited public available data, so there is a limitation, and potential bias in the historical records also, and the model performance could improve with real-time data. I hope so. So in the conclusion, successfully demonstrate ML-based prediction of Falcon and landing, done that, and potentially real-world application for SpaceX and aerospace firms. They have too much scope, and in the future we want to work on like incorporate real-time weather and trajectory data, so we want to work on that. And if we find a large amount of data on weather and trajectory data, so our accuracy of model is also increased, and develop deep learning model for higher accuracy. And I am giving a thank you to SpaceX API, data science community, and my mentors. And thank you for the SpaceX API documentation and various types of research paper, and of course dataset which is I used. So thank you guys. It is from my side. If you have any queries, so you don't hesitate, just ask.